The first problem from the exercise 2.5 on diaphragm equation is written here. Determine all solutions in the integer of the diaphragm equation 56x plus 72y is equal to 40. Now we shall solve this problem. And you see, compare this equation with ax plus by is equal to c, and therefore the given equation is 56x plus 72y is equal to 40, and the value of a is 56, b is 72, and c is 40. Now first we have to find out whether the solution exists or not, and for that purpose we have to find the GCD of a and b. So first we shall find GCD of a is 56 and b is 70 using Euclidean algorithm, by Euclidean algorithm. Or you may see this is simple to find the GCD, but we shall use Euclidean algorithm and see the greater number is 72, that is divided by 56, and the quotient is 1, so 72 minus 56. You may check, the remainder is 16, and now 56 is divided by 16. The quotient is 3, 48, and again the remainder is 8. And now this 16 is divided by 8. Quotient is 2, the remainder is 0. So in this process, the last non-zero remainder is 8, and therefore the GCD is 8. GCD of 5672 is 8. And this 8 is to be expressed again in terms of 56 and 72. So for that purpose, we should consider this is equal to 8. Or before that, we will write the list of equations here. And first is 72. So 72 is equal to 1 into 56 plus 16. Next is 56 is equal to 56 is 3 into 16 plus 8, and further 16 is equal to 2 into 8 plus 0, and the last non-zero remainder is 8. Now this 8 is to be expressed as a combination of 56 and 70. Now last but one equation, second last equation we have to consider 8, and that 8 can be written as 56 minus 3 into 16. So we have to write as it is without multiplying the numbers, and this is 56 is the number, and we should keep as it is, minus 3 times 16 is to be expressed from the first equation, 72 minus 56. And now you may check, this is equal to so we want the combination of 56 into some number plus 72 into other number, and you may verify this is 1 times 56 and this is 3 times 56, means that is 4 times 56, and 72 minus 3 times, so therefore 72 minus, and this is 8. So thus the steps of Euclidean algorithm are necessary to solve diaphragm equation. First find the GCD of these two numbers, and that is 8, and again express it in this form. Now we should check whether this GCD divides the right side number. Here it is 40, and obviously the GCD D divides 40, since D is, we have the GCD is, therefore D is equal to 8, and 8 divides 40. Therefore, the equation has a solution. the equation 1, given equation, we suppose it is 1, has a solution. And now to get the solution, what we should consider is compare equation 1 with this equation 2nd. And we should match one side integer, that is 40. Now we want this integer as 40, GCD to be multiplied by other integer, so that we should get the required integer as 40, because that GCD divides 40. And if you multiply it by 5, we get 40 here. So therefore we multiply second equation by 5 on both sides. Now you note this step. Why we are multiplying by 5? Because we want one side as 40. The sides are reversed. And or otherwise you write this 56 into 4, interchange the side and the equation can be written. So multiply equation 2 both sides by 5. So we get, now while multiplying, 8 into 5 is 40. So one side is obtained. And we should remember, we should multiply, we don't change 56 and 72 because these are required in the equation. So keep as it is, multiply the remaining other integer, multiply this 4 and minus 3 by 5. So this is 56 in bracket 4 into 5 plus 72. Keep the sign also plus here as in the equation, and this minus 3 into 5. Or therefore this is 40 is equal to 56 into 20. Don't multiply these numbers, and plus 72, and this is minus 15. Or you may change the side and compare this. Comparing this with equation 1, what is the solution? You see 56 into x, x is 20, and what is y? Y is minus 15. And we will take this as x naught, y naught, first solution. And comparing this with 1, we have x naught. X naught is equal to 20 and y naught is equal to minus 15 as a solution. So this is a solution of equation 1. You can verify by putting the values. And now all remaining solutions are obtained in terms of by theorem 9. The other solutions are given by last theorem we have studied, and that is 9. All other solutions are given by integer solutions we should have. Given by theorem 9. X is equal to x naught plus b by d times t, or that is equal to x naught is 20 and plus what is the b? B is second integer 72, and what is the d is 8 we have obtained, and times t, or this is equal to 20 plus, so 72 divided by 8, that is 9, 90, and y is y naught minus a by d times t, or y naught is minus 15 minus a is 56 divided by 8 times t, or this is minus 15 minus, so if 56 divided by 8 is 7, so minus 7 times t. And thus where t is an integer, where t is an integer, and that is t is equal to 0 plus minus 1 plus minus 2 etc. And if put t is equal to 0, we get x is 20, y is minus 15. That is the first solution we obtained. Put t is equal to 1, we get 29 here, and put t is 1 means 20 minus 22 as the second solution, and thus there will be infinitely many solutions. So and we are asked only the solutions in integers, all solutions in integers, therefore this is the answer. X is 20 plus 90 and y is minus 15 minus 70 are the solutions of this diagonal equation. Now we shall consider second problem where the solutions are required to be positive. Positive integers must be the solution. You see here x0 is positive but y0 is negative, and if we want the solutions both as positive, then we have to put the other condition also. And for that we shall consider the second problem of that type as determine all solutions in the positive integers. So the problem from the book we shall consider. So this is the recommended book for this paper, number theory, elementary number theory by David M. Berg. And we shall consider a problem, determine all solutions in the positive integers. Positive integers of the Diophantine equation, and the equation is 18x plus 5y is equal to 48. So I shall consider this problem. The second problem I have solved in the notes, you can refer that solution also. So the same method is there, only one more step will be to find positive integers. First we have to get all the solutions, and then we shall consider only those which are positive. And let the given equation be. So the given equation is 18x, or we shall interchange the sides, and I write 48 is equal to 18x plus 5y. So here A is 18, B is 5, and we shall find out the GCD of A and B first and check whether that GCD divides C, that is 48. Now GCD of 18 and 5. Now it is easy to see the GCD because there is no other integer divisor common to 18 and 5 except 1. These are relatively prime, and therefore you may check by Euclidean algorithm. GCD of 18 and 5 is 1. Simple, we have written. And now we want to express this 1 as combination of 18 and 5. And I shall write 18 into some number plus 5 into another number. That is 18x plus 5y. And you may guess, so what should be this? 18 into 3, or what is that number? We shall consider 18 into 2, that is 36. And 5 into 3 is, so 5 into 7, 35. And therefore I shall consider here minus 7. 36 minus 35 is 1. So we are, if the numbers are smaller, by observation we can get it. Or otherwise you do the same procedure as in the first problem. And thus we have 1 is equal to 18 into 2 plus 5 into minus 7. So this is the equation we have. And 1 divides, obviously 1 divides 48, therefore 1 has a solution. So equation 1, here itself we can write 1 has solution. And 1 is written as 18 into 2 plus 5 into minus 7. Now we compare 1 and 2. Now you observe 18, combination of 18 and 5 must be kept as it is. And we want the left side as 48, one side as 48. So we have to multiply equation 2 by 48. Earlier we have multiplied equation 2 by 5 because 40 was the number in the earlier first problem and one side. and here it is 48. So multiply 2 by 48. Multiplying 2 on both sides. By 48. So what we shall get is 48 is equal to, don't multiply to this number, multiply inside the bracket. So that's why I write the number in bracket. So 18, 2 into 48 plus 5. This combination must be kept as it is, minus 7 into 48. Now there is some calculation you would do. 18, don't multiply these two numbers, only multiply the number in bracket. 2 into 48, 96 plus 5 into bracket minus of, multiply 7 and 48. Check this, minus 336. And now why we are written in this form, same form as equation 1. You see 48 is equal to 18x plus 5y. 48 is equal to 18 into 96 plus 5 into minus 336. What this gives the solution, x is 96 and y is minus 336, and we take that as x naught y naught. So comparing this with 1, we get a solution as x naught as 96 and y naught as minus 336. So we write as comparing this with we have x naught is equal to 96 and y naught is minus 336. Whether it is right, we may check. Yes, is a solution. Is a solution of 1, and this diagonal multiplication, and all solutions we should write by theorem 9, and therefore all other solutions are given by x is equal to x naught plus b by d times t, or that is 96 plus b is pi divided by d is 1. So you should note here this is GCD is 1, and you may consider d is equal to 1, and therefore d divides 48 and 1 divides 48, and therefore 1 has solution. And therefore 1 has solution. This is the reason. And 96 plus b is 5 by 1 is 5 times t, or that is 96 plus 5, and y is equal to y naught minus a by d into t. Here b is 1, so y naught is minus 15. Minus 15 minus a is 18 divided by 1t, or minus 19, 15 minus 18t, where t is any integer gives all solutions. So this gives all solutions, and now it is asked to find positive integer as solution. We need positive solutions. So one solution we have obtained is this is also negative, but we want positive solution, and t is any integer. There are infinitely many solutions. We select those which are positive solutions, where t is arbitrary integer or any integer, you can say. To get positive solution, or solutions, we must have, see, x and y must be positive. We must have 96 plus 5t is greater than 0, and minus 15 minus 18t is also greater than 0. Both must be positive. or what this first gives, that is 96 is or 5t is greater than minus 96, we can say 5t is greater than minus 96. You remember, whenever we solve inequality, if you multiply both sides by a negative number, the inequality changes, or if you take the reciprocal, then also the inequality reverses. But here we have not considered the number change in this inequality. We have just transferred or add minus 96 on both sides. And here we consider minus 18t on that side, that is minus 15 is greater than 18t. Now we divide by 5 here, both sides, or this means t is greater than minus 96 divided by 5 and divide by 18 on both sides. Divide by, yes, 18 on both sides, and this gives minus 15 divided by 18 greater than t. So we should check whether our equations are correct. So we have a is 18, yes, that is right, and thus t is greater than minus 19 by 5, and we should consider the integral part of this. So t is greater than divide 96 by 5 and then see the integral part of that. There is a mistake here. We have considered y naught. Value of y naught is minus 336. We have to correct it. Minus 336. Minus 336 is the value of y. We should have to correct it. And similarly, this is positive and this is positive, means minus 336. Minus 336 minus 18t is positive, or this gives minus 336 is greater than 18t, or this means divide both sides by 18, minus 336 divided by 18 is greater than t. We reduce the number, and now we will consider first as t is greater than 96 by 5, that we keep as it is, or minus 96 by 5 is less than t, it is the same. Therefore minus 96 by 5 is less than t, and now here this number is greater means t is less than, and t is less than minus 336 by 18. So that number is divisible by, you see, it is divisible by 6. So if you divide by 6, it is 56, the numerator, and the denominator is 3. 56 by 3, if you check it, divisible by 6. So we have reduced the number in smaller form, and now we have to get what we have written here is t is integer. So therefore fractional values we should not consider, only integer values we should consider, and for that purpose we divide 96 by 5 and see what is the integral part of this number. So first quotient is 1, and that is here 4 remains, then 9, and what is the remainder is 1. So this number is therefore minus 19 quotient, remainder divided by divisor 1 by 5. Check this, is less than t, and we combine it, is less than t, t is less than, divide 56 by 3, and you see the quotient is first is 1, and then now 18, quotient is 18 and the remainder is 2. So therefore this number is 18 minus 18 2 by 3. So t lies between this minus 19 1.1 by 5 and 18 2 by 3. What is the integer value between these two numbers? And you may observe in the number line the numbers decrease in left side. So if you consider this as minus 17, minus 18, minus 19, minus 20. So where is this number? Minus 19 point something decimal. Then that will be on this side. This side. And again minus 18 point something will be number on left side of minus 18. You note this. 18 point something will be on the left side of negative number, left side of this, and minus 19 point something will be left side of this. So what is the integer between these two? That integer is minus 19. So this is the value of t, range for t. T lies between minus 19 point some number, this is written approximately, and therefore t must be 90. Therefore we must have t is equal to minus 90. And now we use this value in this solution that we shall suppose it has 3. So putting this value in 3, we get positive solution. There is one positive solution only, for t is equal to 90. So we put this value in 3. Putting this value in 3, we get x is equal to 96 plus 5 times minus 90, that is 1, and y is, here it is minus 336 minus 18 into minus 90, or you may calculate this number and see what is this number. 18 into 90 minus 90. So and the number is 2 342. So 342 minus 336. So that comes to be 6. So this number y is equal to 6. You check it. Y is 6. And whether the solution is now correct. 18, put x is 1, then this is 18, and y is 6. That is 30. 5 into 6 is 30, and that is 40. So it is right. So y is equal to 6. So thus we have put the value of t as minus 19 in this expression. All solutions. And this only gives only one positive solution, and which is 1 and 6. So this is the positive solution. And this completes the problem. So in this way we can find Diophantine equation. Only solution in integers is asked. There is no need to find out positive integer solution, positive solution. And but if the problem is to find positive, then we have to do this part. That consider all solutions and take the all solutions to be greater than 0 and find the value of t. So this is the positive solution in positive integers. So this is about the Diophantine equation, and this is about the first chapter of number theory. So you should try to solve the problems from the book and also prepare the theory part well. So next time we shall consider the second chapter. Thank you.